Hello everyone, welcome to another part of the P-delta analysis. In the previous part of the P-delta analysis, we have seen that theory related thing. But in this particular part of this P-delta analysis, we will see that whether in our structure we required a P-delta to be done or not. We already know that P-delta is not required for every structure, or we can say a building. So for every structure or building, we have to check that this particular building or the particular structure there is required of the P-delta to be done or not. Now let me open the whiteboard for doing this all the calculation. So first of all, for finding the P delta to be done or not, we have to require a calculation of a stability index. Now it is denoted by Q, and Q is your stability index. So Q, we can call it a stability index here. Now if you look at the formula of the Q, it is your a secondary moment divided by the primary moment. Now what the secondary moment you got it, you have to divide it by the primary moment, then you will get it a stability index. So if you look at the PPT here, which we were discussing here, we have already done this part, that the calculation of the secondary moment and all, and the primary moment also. So if you look at here, suppose that this is the column and is subjected to lateral forces, and the P is there, and there is a lateral deflection also, and the H, you will get it, that is V multiplied by H, this is your primary moment, and this was your secondary moment. So if you want to calculate the Q, then this will be a secondary moment, that is P multiplied by delta, and you have to divide it by V multiplied by H. So this will become your stability index. So this was the condition where we have a fixed support columns and just a single column here. Now instead of the column, let's suppose that if you have any a building or whole structure. So let me open first, let me write this formula in our whiteboard first of all. So the secondary moment will be of P multiplied by delta, and your primary moment will be V multiplied by H. Now this formula will get when there will be a column, and just suppose that I have a fixed support column here at the base, and I have subjected a lateral load to this column in the form of V, and due to this lateral forces we got a deflection here in the form of delta here. So there will be P along with that, and let's suppose that this is a small h, the story height. So there is a P multiplied by delta, this is the P, what actually P multiplied by delta, and V multiplied by H, you are getting a primary moment. Now this, if you divide it a secondary moment by primary moment, then you will get a stability coefficient. So this was the case where we were having only one single column. But when you will do the real project and all, where there will be a whole structure will be there, and in the whole structure there will be a lots of column, there will be not a single column will be there will be a lots of the columns. So the calculation there will become a little bit challenging, because if you are going to find out that what actually is stability index, then you have to do some tricky calculation there. Suppose if we have one single column, then calculation of stability index becomes very easy. But for a lot of column, these calculations and all, it become little bit harder there. Now let us understand the calculation there first of all. Let us consider through the storage wise. So this is the storage I have, and in a storage I have a summation of all the P here. Then there will be a lateral deflection also, which we will count as a delta here. Then there will be a lateral forces acting at that particular storage. Then there will be a, we can say that is acting in the form of V here. Also there will be a height of the story. So when I am considering here, then I have to look at the summation of all the P there. What is acting on that? What is the lateral deflection we are finding in that particular storage? What is the lateral forces we are finding in that particular storage? And what is the height of that particular story? So if you formulate this thing in the formula here, when I will open my whiteboard to formulate this, if you will formulate this formula, it will be summation of P multiplied by delta. So delta, and that has to be divided by the forces, lateral forces, and there will be H, that is a story height. Now if I will write here summation of P, which will be sum of axial load on all columns in the story. So this will be P. So if I am counting this particular story here, then my P will be sum of all the axial load. So all the axial load which will come here, which will be acting in the story, I have to count it here, the summation of P there. Now if you look at the next thing is that your delta. So the delta which we already discussed you that, so delta will be elastic first order lateral deflection. So if you look at the delta which be elastic first order lateral deflection. So the deflection what is caused by the forces will be this delta. Now if you look at the V will be your total lateral force acting on the story. So what the total force you are acting on the story? Let's suppose that this is my story here, and in this story the total lateral force is acting of 500 kilonewton. So this will become a V there. Now only one thing is left, that is your H. Your H is nothing, it is just a height of your story. So height of your story is your H. So if I am counting this particularly this story, then this will become your H. Now I think you have understand the calculations, that what are the things you required for finding out the stability index. Now I think we are very clear about that calculation. Now if I will come to the whiteboard here, when you will carefully watch this formula, you will find one interesting thing here, that we are having a delta divided by V. So delta divided by V is your stiffness. So if you remember that I have already discussed about that, when you have to find your stiffness, then what the deflection you are getting and what the forces is applied, that is only the stiffness we have. So if you just want to rewrite this formula, you can rewrite this as like this. So this formula will be rewrite like summation of P, and there will be a K here, and we have left with only one thing, which will be a height here. So this formula will be rewrite like something like this. So you may also write like summation of P divided by K multiplied by H, because this delta divided by D will become your completely a K here. Now you might be thinking that why we have introduced a K in this formula. The reason why actually I have introduced a K, because when you find out the stiffness, it is very easy to get it from Etabs. So you can go into the sort tables, and from there you can easily find out the K values from Etabs. Now for finding out, the main motive is our to find out the stability index. So for finding out the stability index, first of all let us find out the K in that particular formula, and after calculating the K, we already know that when we will get a K, then we are left with only one thing to be calculated, that is a P here, because H you already know that H, the height will be 3 meter. What the height you have specified, that thing only is left here. Now the formula becomes quite easy for us to find out the stability index here. Now I think you have understood why actually I have introduced a K to easy our calculation. So if I will find out the K, only thing I have to worry about only to find out the P there, because H is, you already know that what H you have specified, what height you have specified, it's very easy to find out. Like in this particular structure, if you look at, I have specified a 3 meter, I think I have specified here. So you can easily go to edit option here and grid system here, you will modify this, you will find the height here easily. You will get it Q, and the Q will be calculated in the both of the direction. So it will calculated in QX, also it will calculate in QY. So for the both of the direction, you will get it Q values, because if you remember the stiffness we have calculated in the previous lectures also. In the previous lecture also, if you look at it, I have calculated the stiffness in the X direction, also we have calculated stiffness in the Y direction. So here also we have to find out the K here, and that K has to be calculated in the both of the direction. So there will be a 2Q calculated in this particular calculation of stability index. Now the Q value, which is the stability index which you have calculated, if it is greater than 0.0 0.05, then P delta we will apply. So this is the condition we have to remember. So this is a very important condition which I am writing here, that if the stability index, that is a Q value, you have calculated, and if it is greater than 0.05 here, in that case the P delta becomes a dominating there, and we have to include the P delta effect in particular that type of structure there. And now if it is lesser than 0.05, in that case the P delta is not that much dominating, and you can ignore the P delta effect in that type of particular project there. You can look at the 0.05 here. This means that if you remember that in the calculation of the stability index, I already told you that a stability index is secondary moment by the primary moment. So if you find it in the terms of percentage, then it will come the 5%. So if your moment is having more than 5% as compared to the primary moment, the secondary moment is more than 5%, in that case you have to calculate it, or we can say that you have to take it account of the P delta in your structure. Now come to the Etabs, and in Etabs we will open our project which we are doing, and in that project we will find out that the stability index, and we will see that whether our structure, or we can say that our stability index is also exceeding a 5% or not. If it is exceeding the 5%, in that case we have to count it the P delta effect in our structure also. So let us do that. So come to the Etabs. Now unlock the model. Now let us define first of all the P delta here. So go to define option. You will find P delta option here. You will go to the iterative based on load. Here you will add a date with 1.2, then you will add a live with 1.2, then you will add a floor finish, that will be 1.2, wall load 1.2, live load again greater than 3, that will be 1.2. So right now I am not explaining that why I am taking 1.2. This I will explain you the last part, where we will explain you that why we are taking only the gravity load there. So this I am keeping, just I am taking that particular scale factor. This thing again I will repeat it once again in the part 3, where we will see that why we are taking 0.2 only as a scale factor. So can we take it more scale factor and all, we will discuss that thing in the later classes. You give it OK. Now you run the analysis. Now in the calculation of stability index, the first thing you will find here, which will be a K here. So you are going to first find out the K value, which is this value you are going to find out. Now open Etabs here, and you will go to display option. Here you will go to sort table option here, and in this you will get a structure output. Here you will get it other output option here, and this you will find a story stiffness here. You will click this table of story stiffness, and you will give it OK here. So the story stiffness table is calculated, or we can say we have found the story stiffness table. Now you will take a blank sheet of Excel sheet. In this first you will name a story here. So you will give it a story. In second you will give it K, which is stiffness, and X, which is gives you direction here. So again you will give it KY, which will be a Y direction stiffness. Now you give it length, that is height of the story. Now here you will give it P here, that will be summation of all the axial load, and here you will perform your, now here you will give it a QX. So this stability index I am given this QX for the stability index, and this we have given a check here. So if your stability index value will be greater than 0.05, in that case you have to require a P delta, you will give it this condition here. Now same thing what you have given here as a Q, you will give it QY also here, and here also you will give it a check here. Now you can give it this as a check Y, and this you give it check X. Now what you will do, you will copy the story here. So in the Etabs model, you will copy the story from here, and you will paste it here. Now it's time to paste the stiffness of the K here. Now come back to your here, and in the output case, we'll select only spec x right now. So spec x, you take out the stiffness here, you copy it and you paste it here. Now same thing you will do for the y also. So in no output case you give it y. Now take the stiffness of this y, select it and paste it. Now I told you the height will be 3 meters same, so you will give it 3 like this. Now it's time to input the value of summation of all the p, that is axial forces. For getting this p value, let us come to Etabs. Here you will define one load combination which will be, you can name it load combination P, and this will be dead load plus live load. So in the dead you will keep it 1 as a scale factor, live also you will keep it 1 as scale factor, and floor finish also 1, water load also 1, live greater than 3 1. After defining this load combination, you will give it OK. OK. After defining the load combination, you will go to display option. Here you will go to sort table option. In the analysis result, you will go to the structure output. Here you will go to the other output items. Then finally you will get a table of the story forces. So you will click this and you will give it OK. So right now which we are looking, this is a table of story forces. So in the table of the story forces, first of all you will filter the load combination which you have defined it. So in the output case you will do the right click and you will only select the load combination which you have defined right now, and in the location you only select the bottom one. So for the OST you are getting the p value, that is 1243, like that you will get it. You will copy this and come to the Excel sheet and you will paste it. So like that you will copy the p value and you will paste it in the Excel sheet here. Now let us come to the next table which is of Qx. So Qx is your stability index. If you want to get the value of a stability index, the formula you have to keep it is that summation of all the p divided by a stiffness of the x direction, and that has to be multiplied by h. So in the formula we already have p value, so this is the p value I already have, kx, that is stiffness in x direction, which I have. Now we are left with the height of the story which is h. So height of the story already I have here. So all thing we have, let us formulate this thing in our Qx. So we will apply the formula here. So let us select first of all this table, and here you will give it equal to sign here, and you will start with the bracket sign. After that you will select the p table here, then you give it divide sign, then you start with the bracket, then you give it a stiffness, that is x direction, then you give it multiplication sign, then there will be height, then you close the bracket, again close the bracket. Now you give it OK. So you got the value of Qx in the OST level. Now you will do like this. Now you can see that for every story we have calculated the Qx value. Now come to the next table which is of check x. So in this check x table we are going to apply a logic. So the logic is if Qx, so this I am talking about, if Qx value of particular stories is less than or equal to 0.05, then that story will come under a non-sway story. And if the condition is reverse, if Qx is greater than 0.05, in that case the story will be a sway story. Now if you are getting a non-sway story, in that case no need to apply the p delta, and if you are getting a story which is a sway story, in that case you have to apply the p delta. Now I think you have understand that what actually we required to apply the p delta and what we actually do not require to be applied a p delta. So if this value of qx is greater than 0.05, then a story will come under the sway story, and in that case you have to apply the p delta. And if this value is qx value is equal to or smaller than 0.05, in that case the story will come under the non-sway, and we don't need to require a p delta analysis in that particular case. Now let us apply this logic in this particular table. You will select this table, you will go to the formula option here. In this you will get a logical option here. In this you will take if, and you will give it a logical test which will be qx smaller than or equal to 0.05. If this logic is true, then a story will come under the non-sway. So we will give it a story is non-sway, and if this logic is false, then a story will come under the sway. After giving this logic, you will give it OK. Now you will give it this formula for every story. For every story this logic is applied. Now come to the next table, which is of qy. So how you have calculated the qx, same thing you have to calculate the qy, but only thing you have to do changes here, that instead of giving a stiffness in the x direction, you will give it a stiffness in the y direction. So this only change you have to do here. So you will select this table, you will give it equal to sign here. After that you will give it, you start with the bracket first of all. After that you give it summation of p, then you give it divide sign, then you give it a stiffness in the y direction, and before that you please start with the bracket, then you give it multiply sign, then height of the story will come, then close the bracket here and give it OK. Now you copy this formula for every story. Now come to the next table of check y. So what condition or logic you have applied for the check x, the same logic you have to apply for check y also. So let us apply that logic. You will give it equal to sign first of all. You go to the logic option, go to the if option here. Now let us apply the logic test here, that if qy is greater than, or you can start with a smaller than or equal to 0.05, and if this value is true, then a story will come under the sway story, non-sway story. So story is a non-sway. Now if this value is false, then a story will come under the sway story. You will give it OK, and you will copy this formula for every story. Now in the check y, you will look at here that every story is coming under the non-sway only. The story which is sway is required to apply the p delta, and the story which is non-sway is not required to apply the p delta. Now we have came to end of this part, where we have seen that how we can calculate the story is becoming a non-sway and how the story is becoming sway. So this thing again I will teach you once again in the column design. So when we will do the column design, when we will study there more deeply that what actually the sway columns and how actually the non-sway columns are there. But here you only need to learn here that the column which is coming under the sway column, there will be a p delta applied, and the column which is coming under the non-sway column, in that case you don't need to apply the p delta analysis. That thing only you have to remember from here. Now in the next part of the p delta analysis, we will learn more few things regarding your p delta definition here. So how we are defining the p delta here, we will learn this thing more deeply in the next part of the p delta analysis classes. Also, how to include the p delta in your load cases, that also we will look at in that part of your analysis classes. Also the load combination which you are taking for the p delta definition, that I will also discuss in the next part of the p delta analysis classes.